Welcome to the notebook for Module 3, Building Multi-Stage Reasoning Systems with LangChain. In this notebook, we're going to cover two pretty cool AI systems using LangChain. The first, codenamed Jekyll Hyde, will be a LLM chain-based model that'll have one large language model used to create a comment that reacts to a piece of content that we give it. And the second LLM will be used as a moderator to look at how the first LLM behaved and whether or not the content it produced was appropriate. It'll either block what the first large language model said, or it'll allow it to be posted on some hypothetical website. Our second system, codenamed Daisy, will be an LLM agent that will be used as a virtual data scientist, and we'll give Daisy some data to work with, and we'll also ask it to search the web for some data to analyze. Let's dive in. Firstly, your learning objectives. By the end of this notebook, you'll see how we can connect prompt templates, create new prompts with different inputs and different data, and connect them with LLM chains so that we can have a multi-chained prompt and LLM-based system. We'll create sequential chains using these multiple LLM chains, and then we'll build up our LLM agent and give it some tools so that it can do some pretty cool stuff. To run the classroom setup, run this cell here. This will set up some of the environment variables that we might be needing, and we'll also run the pip install for a couple of the tools that we'll need later on. We'll just give this a moment to finish running. Okay, that's all set. Now we can look at some of the API tokens that we'll need for this notebook. There are a number of different large language models that we could use at every point in this notebook, and Hugging Face has a wide variety of different choices for us to use. To do this locally, we'll need to use the Hugging Face Inference API. And if you don't have an account on Hugging Face, you can sign up using the instructions here. All of this is free to use. Just follow these steps provided. Likewise, we're going to be using Google Search, and so we need to use the SERP API, and the information needed to get an API token is also listed here. Once you have your API tokens for both SERP and Hugging Face, we can move to this next cell where we would put them in either with plain text, which we don't recommend, or using the Databricks secrets utility. We showed how to create the Databricks secrets and incorporate them into your workspace in the Databricks secrets video, so refer back to that if you've forgotten or haven't seen how to do that. I have mine set up, so I'm going to run the cell command 9 and import my Hugging Face and SERP API keys. So let's take a look at the Jekyll Hyde self-moderating system. As I mentioned before, in this section, we'll build an AI system that consists of two large language models. Jekyll, the first large language model, will be designed to read a social media post and then create a new comment. Jekyll can be moody at times, sometimes it's level-headed, so we're not sure whether or not the comment it posts will be appropriate for our social media platform. We're going to have a second large language model, Hyde, be a moderator. It will take a look at what Jekyll has said and determine whether or not it's appropriate to pass on. Let's jump into this. The first step will be to build the prompt so that Jekyll can create the comment. If we look at command 12, we can step through and see what this code says. From the LangChain library, we're going to import the prompt template, and we'll also need NumPy. Our prompt template, like we saw in the lecture slides, looks like this. We give it an instruction. So in this case, you are a social media post commenter, and you'll respond to the following post with a sentiment response. You can see here that sentiment is a variable, and we'll come to that in just a moment. And then the post that we give it will be the social post, which is also a variable. We then finish our prompt template by having a comment and then colon, indicating that the large language model should then finish or respond to this prompt with the comment on the social media post. Using the prompt template class, we can instantiate a Jekyll prompt template, and we're going to give two variables as an input. You can see on line 14, sentiment and social post. Finally, the template that we're going to give the prompt template class is the Jekyll template, which we just created. So now we have everything ready. We can start to build up what our prompt template will be made out of. So we're going to assume that the sentiment that Jekyll has is somewhat randomized. We'll start by assuming that it's a nice sentiment, but we'll include some randomness so that maybe Jekyll wants to be mean with its response. We'll then create our social media post, which we've created here. I can't believe I'm learning about LangChain in this MOOC. There's so much to learn, and so far the instructors have been so helpful. I'm having lots of fun learning. Hopefully that rings true for most of you. Okay, now we can create our Jekyll prompt by instantiating from the prompt template. We use the .format command and give the sentiment value from our random sentiment that we just saw and our social post that we just created. So now let's run our prompt and see what it looks like. So now we have our Jekyll prompt. You're our social media post commenter. We will respond to the following post with a mean response in this case. And so you can see we have the social post that we just created. Okay, so now Jekyll has its instructions. We need to give it a brain. By that I mean a large language model. Now we can use a Hugging Face model for this, or we can use an OpenAI model as well. The main difference between the OpenAI models and the Hugging Face models are, of course, the cost and in some cases the performance. I tend to find that the OpenAI models are far more performant than the open source values, though you do have to pay. It is worth noting that every time we interact with an OpenAI model with a fairly small prompt, it costs less than $1. Just for this example, I'm going to use OpenAI, but feel free to use some of the Hugging Face options as well. If you want to create an account for OpenAI, the instructions to do so are here. You can see that it does allow a $5 credit when you sign up, but you'll need to have a credit card attached to begin. Like before, I have my OpenAI API key set up in my secrets, so I'm going to set that up. And now we can start to build the Jekyll part of this model. From LangChain, we're going to grab the Hugging Face pipeline. As just a demonstration here, we have the code for both the OpenAI approach, but also if we wanted to use, say, GPT Neo 2.7, we could use this code here for our Hugging Face pipeline. As I mentioned, I'm going to use the OpenAI model just for simplicity, but feel free to choose whichever you wish. We also need to include the OpenAI LangChain LLM, and we're going to be using the text Babbage 001. This is not the most performant model that OpenAI uses. I just want to show you some of the variability that we have when we select different models from different providers. So now let's instantiate the model for the Jekyll large language model by running this cell. And now Jekyll is ready to go. You can see we get a warning that this model is not the default parameter. Don't be alarmed. This is just a prompt from LangChain to tell you that you're not using the latest version or the latest offering from OpenAI. There are a number of different options that you can use in the OpenAI model, so pick whichever is best for you. Okay, now that we have a prompt and a large language model for Jekyll, we can now build our prompt LLM chain for Jekyll to see what it says. This is what we saw in the lecture notes as well. For safety, we're also going to import the profanity library from Python, which just prevents any profanity from being presented on screen. We're going to import the LLM chain from the langchain.chains library, and now we're going to build up our Jekyll model. To do this, we can see our Jekyll chain is going to be a LLM chain. We pass it the Jekyll LLM. We're going to pass it the prompt from the Jekyll prompt that we created. We're going to call the output of our Jekyll chain. We're going to give that the name Jekyll_Z. And we're going to set verbose to false in this case. To run our chain, we use the .run command. And so we can store what Jekyll said as Jekyll chain.run and pass it the input variables of random sentiment and social post. This is slightly different to what we did earlier, where we built our prompt explicitly and printed it out. In this case, we do all of this at the run command time because we're building this chain. Before we were just building the prompt on its own. Because we're building the prompt inside the chain, we pass in the input variables this way. Before we see what Jekyll says, since we know it is going to be mean, we'll just pass it through the profanity sensor for safety. Let's run this command and see what Jekyll said. Interesting. Jekyll has some thoughts on whether or not we should say anything at all. We can take this however we want. Please keep in mind the generative AI approach to creating comments can be quite challenging at times. You'll never get the same result twice, typically, and sometimes you might read something that's not quite so pleasant. For now, this is about as good as we could hope for with a mean sentiment, so let's keep going. Now that we've built our Jekyll part of the Jekyll Hyde system, let's move on to our moderator, Hyde. We can see step by step how we'll build this, and I've included pretty much all of the steps that we did for Jekyll, but this time for Hyde in one cell. So the first step is to build our prompt template, and you can see here we're telling Hyde that it is a moderator of an online forum. You are very strict and you won't tolerate any negative comments. And you'll look at the commenter from a user, which we know to be Jekyll. And if it is at all negative, you'll replace it with symbols and just post that. However, if it seems nice, you'll let it remain as is and repeat it word for word. So we're giving it then the original comment, which is Jekyll _said. And if you remember, that was what we called the output variable from our Jekyll chain. And then the edited comment is the signal for Hyde to then replace the negative sentiment with symbols, or if it thinks it's okay, it'll just pass on the original comment. Because the original comment that we're dealing with isn't overtly negative, it may actually allow this one through. We're using the prompt template again, and we're going to have the input variable of Jekyll said, which was, recall, the output of the Jekyll LLM chain. We're also giving the Hyde template so that we can pass in the Jekyll said variable later on. Next, we need to give Hyde a large language model to work with. And because this is the moderator, we're actually going to give it a more advanced model. This is a completely contrived example. There's no reason to necessarily give it a more advanced or less advanced model. We just wanted to do this for some variety in the notebook. We're going to give it the Text DaVinci 003, which is the more advanced version of the OpenAI model. We pass that in on line 21. And now we're ready to build up the chain for Hyde. We pass it the large language model, we pass it the prompt template, and we're also going to set verbosity to false. You can set it to true and it will show you each step. We'll look at when verbose is true later on. Now we can run the chain with what Jekyll said and see what Hyde says. Again, we get the warning about the default parameter. Again, don't worry. It looks like Hyde was happy to repeat almost all of what Jekyll said. However, it seemed to have an issue with the word after Yule. Not quite sure why it didn't like that word, but who knows what these things ultimately think under the hood. But you can see now we've connected one large language model to another large language model and had them almost compete in some way, that one there's a check and a balance. Now that we've got each of these Jekyll and Hyde LLM chains together, we can build this into a more modularized system. We can combine both the Jekyll chain and the Hyde chain into a sequential chain where all that we need to do now is give the inputs at the start of the chain and end up with the output. The Jekyll Hyde chain is then going to be a new class of LangChain chains called the sequential chain. The sequential chain expects a number of chains to be passed, and what it will do is take the output of the first chain, pass that to the input of the second chain, and so on until the end of the chain. We have 2 chains here, so it's just going to interact with 2 of them. We'll still need to give the input variables of sentiment and social post. However, we don't need to give explicitly the output variables, as we've told in the definition of Jekyll chain that the output will be called Jekyll said, and in the Hyde chain, it knows to look for the input variable of Jekyll said as well. So that will happen behind the scenes. We're going to run our Jekyll Hyde chain using the random sentiment, which is still set to mean since we haven't rerun that cell, and the social post that we created. Because we're rerunning these chains again, we'll get different results for what Jekyll said. So now we can see we're entering our sequential chain. And interestingly, it looks like Jekyll said something to the sense of, you should probably be grateful that you're taking the time to learn about LangChain in this MOOC. The instructors have been so helpful and you're having a lot of fun learning. Not quite sure what Hyde thought of this, but apparently that all went through just fine. Feel free to keep playing around with this to see the kinds of things that Jekyll can say. This is our first example of how to build LLM chains with both prompts and multiple large language models. And now we can move on to our second AI system, Daisy.